So this is the current design of our application. We have our single EC2 instance, which is processing all the requests. So what is the issue with our current design? So let's say the number of requests to our server are increasing day by day. So now our CPU and RAM maxes out. Now the latency increases and uh, and some of the requests are also getting timed out. So what we can do here? Here comes the concept of vertical scaling. What we can do is we can add more power to our EC2 instance, more power to our machine. It is called scaling up. We just add the power to the same EC2 instance. So currently, for example, the instance type of our EC2 instance is T3 micro, which is the smallest instance uh, uh, AWS provides. There are different instance type, so we can choose a larger one. So we can choose a larger CPU, a larger RAM. This is vertical scaling. Even if we scale vertically, what are still the issues with our design? So the issues that remains in the design are that our system is not fault tolerant. Every part of our system is a single point of failure. For example, if my Docker container is down, then my whole system is down. If my front end is down, if my back end is down, if my database is down, everything in my system is currently single point of failure. Or what if I want to deploy some changes which requires the downtime? So at that time, no requests can be processed and our website is down. So here comes the concept of horizontal scaling. What we want to do is we want to add more servers in our architecture so that even if some node is down, still our request will be processed by other servers. So this is what we are going to do here. We have one EC2 instance. We are going to create exactly same another EC2 instance so that even if our one server is down, the other server can handle the requests. So to do that, we need to create an exact copy of our EC2 instance that we created. AWS provides us a feature to copy whole image of an EC2 instance. We are going to use that and create an exact copy. We just need to add the IP address of our new EC2 instance in our environment file, and our new server is up. So let's do that. So this is my current EC2 instance. I'm going to create an image. Let's name it. As soon as the status of this uh, image is available, we can create another EC2 instance with this image. So my image is ready. Now I'll create another EC2 instance from this image. I'm going to name it Multiply Server and choose from the AMI that I created now, this Mergify server image. I'm going to use the same key pair that we used for our server one. We will use an existing security type that we used for our server one. Yeah, let's launch the instance. Okay, it's running. Let's connect and add the IP of the server in our environment files. Yeah, so our repo is copied. All the installation that we had done on our all of that is here on server 2 also. So I'm going to add the IP of our this system here and also change the front end base URL. I will also change the front end env file. We will create, we will build our Docker containers here. So our build is ready, and both our front end and back end containers are running. Uh, let's do the data migration as we did on server 1. Yeah. So now our website should be ready for this server as well. Yeah, our website is running. Yeah. So let's log in. Yeah. So uh, now our second instance is also up and it is working. So now we have two servers running for our application. So even if one server is down, the user can send request to the another server. But there's a problem here. We can't give link of all our servers to user. We need one universal link for that server. Here comes the concept of load balancing or a load balancer. So a load balancer acts as a reverse proxy which sits in front of your servers and accepts all the incoming requests and distribute it amongst the servers. So there are different strategies which a load balancer can use. Most common one is round robin. One request it sends to server 1, then server 2, then another to server 1, then another to server 2, like this. We can change the strategy to use based on CPU utilization or RAM utilizations so that there's an equal amount of work done in both the servers. So what a load balancer does is it checks the health status of our servers. If health check of one server fails, then it stops sending requests to that server. That's how it makes our system fault tolerant. So AWS provides this feature of having a load balancer in front of our EC2 instances. So first we need to create a target group. In that target group, we need to add the servers. Then we need to add the health check links. So each server should have a get API of health check. If that API responds with a success response, then the load balancer knows that the server is running. Else, there's an issue with that server, then it will not send any request to that server. So let's create a load balancer for our two instances. Here first we need to create target group. So let's first create target group for our front end. Let's name it Mergify front end TG. So our front end is available on root. So if our front end's root path is available, then it means that our front end is running. We will add both our servers. Port we will choose for front end. It is running on port 3000. Okay, let's create a target group. Now we will create target group for our backend. So for the health check of our backend, because our backend is available on slash API slash, we haven't created a health check path, but we can use any get API from our APIs. So I'm going to use this list products API, that is slash products. So API slash products. Then, okay, we'll name it Modify backend PG. Add both the servers, port 8000. Let's create a target group. Okay, so we have two target groups for our front end and back end. Now let's create load balancer. Going to create a load balancer. We'll use application load balancer. Let's name it Mergify LB. Let's choose all three so that our load balancer is available in different areas. For security group, I am going to use for now default only. We have to do some changes in our security group to make it working. We'll do that later. Then target group, we need to target our load balancer to front end. That we need to take care. We need to target it to front end. Let's create load balancer. So our load balancer is active. So now whenever there's a request to my load balancer, because I added front end in my listeners. Here, if we check in my listeners, I have added the front end. So whatever request come to my load balancer on port 3000 will be forwarded to my this target group, my front end target group. Okay, in which I have two servers running and one is down, it says. One is unhealthy, one is healthy. So let's check what's issue with our first server, why it's down. Let's connect to our first server. Okay, so our Docker containers are not running. I guess when we created the image for our instance 2 from instance 1, that's when it restarted the server. So our Docker containers are stopped. So we'll build again. First, let me delete all the Docker images previously. By the time the Docker containers are getting started, uh, we need to do one thing. We want our load balancer to accept request from anywhere in the internet. So let's check its uh, security group. Okay, so it is accepting request from all traffic. So there will not be an issue here. One thing what we need to do is now we need to stop the incoming request from public internet in our EC2 instance. We want only the request should come from our load balancer. So in our EC2 instance, in our EC2 instances security group, I am going to block or delete all the inbound rules for internet. Okay. So these inbound rules that I have, so I'm going to delete these two and I'm going to add another one, port 3000. What is the security group of my load balancer not coming here? Okay, this is the default security group. Hmm. Let's create another one. Let's add the security group of our load balancer here. and save changes. Okay, now our EC2 instances are only listening to our load balancer. Okay, so our build is ready and our container should be up. Now my health check will be okay for both my servers. So I'm going to check that. Yeah, too healthy. So my both my server 1 and server 2 are running fine. Means all the requests that are going to my load balancer will be passed on to one of these servers. So now I'm going to use my DNS name of my load balancer. It's not working. Our target group is giving health check as fine. So I guess there's an issue with security groups only. So I am going to create a new security group for this. Let's remove this. Let's create a security group. ALB security group. Let's add port 80 for HTTP request. Let's add another one for HTTPS connections. Let's create. Let's create this. In our EC2 instances also we need to change because we changed the security group of our load balancer. We need to add our new security group here. So let's remove this. We need to add our LB security group. This our new LB security group. In our load balancer, it remove this. I'll modify LBSSC we need to add. Now let's check. Yeah, now it's working. Now all the requests that will be sent to this load balancer will be directed either to my server 1 or my server 2. And both my servers are running. So I can check the health status of my front-end servers from here, from target groups. So both of my front-end servers are healthy. If there's any issue or any server is down, I can see here. So even if my one server is down, my other is up. So what's the issue currently? So let's look at the current design of our system and see what's the current issue. So I have my load balancer here. It is sending request to either my server 1 or server 2. It is only sending request to my front-end servers. Now all the request that comes to server 1 will forward to only to backend of server 1. Why? Because I haven't configured my backend in my load balancer. So all the request that comes to server 1 front end will go to the server 1 backend. Yeah, there's a distribution on the front end level, but there is no distribution below. So what I need to do is I also need to add my backend servers into the load balancer. I'll add a rule that all the requests that comes from /API, they will be redirected to my backend servers in my load balancer. I have already, that's why I created target group for backend also. So I have already created my target group for backend. They are currently unused, too unused because we haven't added them in our load balancer. So let's do that. In my load balancer, So what I am going to do is I am going to add a rule here. Uh, Based on path, because my backend APIs are starting with slash API. So if any request comes from slash API, then it will be forwarded to my backend target group. Else, if no other rule applies, then it goes default to my front end. So let's name priority value. We give it 1. So now we have added our priority value that if my path starts with slash API, then they'll be redirected to my backend. Otherwise, they'll go to my front end. So, so here, if I apply slash API slash, let's say, sign up or anything, it's not accepting because we need to add the load balancer IP in my environment files. My health check will also not be working currently because I need to add the IP in my environment file in allowed host. So let's do that. My target host now from unused, it becomes unhealthy because the Django server is rejecting the request from load balancer because we need to add them in our environment files. So let's do that. So here, now we don't need any of these server IPs. I just need to add my load balancer link here also. And my front end base URL is also now my load balancer URL. Let's save this. Let's go to our front end environment file. Let's change this also. Let's save this. Let's check the same. Let's do the same for our second server. Let's change the front end environment file also. We also configured our backend target group into our load balancer. So any request with slash API will be forwarded to my backend servers. सो पहले क्या हो रहा था कि जो भी मेरी रिक्वेस्ट लोड बैलेंस से डिस्ट्रीब्यूट हो रही थी या तो मेरे सर्वर 1 के फ्रंट एंड पे या सर्वर 2 के फ्रंट एंड पे, वो उन उन पर्टिकुलर बैकएंड पे ही जा रही थी। तो इस वाले फ्रंट एंड की रिक्वेस्ट इसी सर्वर के बैकएंड पे जा रही थी, इस वाले फ्रंट एंड की रिक्वेस्ट इसी वाले बैकएंड सर्वर पे जा रही थी। सो इट्स कॉल्ड टाइट कपलिंग। यहाँ पे इशू क्या है, ये वाला कंटेनर मेरा किसी तरह से स्टॉप हो जाता है, तो अब जो भी रिक्वेस्ट मेरे इस फ्रंट एंड पे आ रही थी वो फेल होने लग जाएंगी। सो अभी मैंने क्या किया कि मेरे जो मेरे बैकएंड सर्वर्स हैं उनको भी मैंने लोड बैलेंसर पे कॉन्फ़िगर कर दिया। सो जो भी मेरी रिक्वेस्ट आएंगी फ्रंट एंड पे, नाउ फ्रंट एंड जो है वो लोड बैलेंसर की एपीआई कॉल करेगा। सो लोड बैलेंसर को कॉल किया विद स्लैश एपीआई, तो लोड बैलेंसर को पता चल गया कि ये वाली रिक्वेस्ट जो है अब मेरे को बैकएंड वाले सर्वर से पे भेजनी है, तो वो दोनों में से किसी को भी चूज कर सकता है क्योंकि मैंने टारगेट ग्रुप में ये दोनों बैकएंड सर्वर्स डाल रखे हैं। सो नाउ इवन इफ अगर मेरा एक ये सर्वर डाउन भी होता है तो ये फ्रंट एंड डिपेंड सिर्फ इस पे नहीं करता, वो लोड बैलेंसर को ही रिक्वेस्ट भेजेगा और लोड बैलेंसर इन दोनों में से किसी को भी भेज सकता है। तो अगर मेरा एक डाउन है तो लोड बैलेंसर सारी रिक्वेस्ट मेरे दूसरे सर्वर को भेजेगा। सो मेरे फेल नहीं होंगी रिक्वेस्ट। सो ये वाला पार्ट हमने कर दिया है। लेट्स चेक द टारगेट ग्रुप्स ऑफ आवर बैकएंड and see if they are healthy. I think they will not be because there's still an issue that we need to check. Let's check. इट्स एनएलई। तो इशू क्या है यहाँ पे कि मैंने अलाउड होस्ट में अपने लोड बैलेंसर की आईपी तो डाल दी, पर अलाउड होस्ट में और कुछ नहीं डाल रखा। तो मेरी बाकी जो भी रिक्वेस्ट है ना, वो फेल हो रही है। तो हेल्थ चेक की जो रिक्वेस्ट जा रही है ना, वो हेल्थ चेक की रिक्वेस्ट मेरी फेल हो जा रही है। सो ये इशू हो रहा है। सो मेरे को ये फिक्स करना है। तो मेरे को आईपी ऐड करनी पड़ेगी अपने अलाउड होस्ट में। तो अगर मैं तो अगर मैं अभी देखूं अपने EC2 इंस्टेंस पे, अगर मैं लॉग देखूं तो या ये जो एरर आ रही है कि we need to add this IP, so इस सर्वर की प्राइवेट आईपी है, so I need to add this in my allowed host. Let's do the same for our second server. Let's restart the containers. Now the health check should be running fine. Yeah. So now my both backend servers are also healthy. We can see that both of our servers are healthy. So now we have applied load balancer over our front end and also over our backend. So we have two front end servers, both are running. So if any request comes to the load balancer, it will be redirected to any of these front end servers. Or if any of the request comes to load balancer with slash API, then it will be redirected to any of the backend servers. So here I have made my system fault tolerant, that even if my one front end container is not working, or one of my uh, instance is not working, still my system can give a response. And it is helpful in cases when we want to take downtime. So let's say I want to restart my server one. So I'll first restart my server one, and when the server one is up, I can restart server two. In that case, I'll have zero downtime and my restart is also done. Now let's come to the design, the architecture that we are currently on, and what are the improvements that we have done from our previous architecture, and what better can we do in the next. Okay, so this is our current design. So when a client makes a request, the load balancer either direct it to server 1 or server 2. So any request with slash API will be directed to the 8000 port, that is our backend server, and other request goes to the front end. So from our previous design, we have made quite a bit of progress in terms of fault tolerance. Now there is no single point of failure in our servers. Still, there are quite issues in the design. We're going to discuss next what are those issues and we will try to fix them. For now, bye bye.